So we start by remembering that slope is rise over run, or the second y minus the first y over the second x minus the first x. So because we've reviewed this already, I'm going to let you do 1, 2, and 3 by practicing finding the slope. But on number 4, we want to look at each of these lines and decide whether they are parallel, perpendicular, or neither. So my first line is line F, and it's the green line, and it's rising 1, 2, 3, and running 1, 2, 3, 4. So 3/4 is its slope. The second line is the blue line. It's rising 1, 2, 3, and running 1, 2, 3, 4. So 3/4 is its slope. The red line H is falling 1, 2, 3, 4, 5, 6, 7, 8, and then running 1, 2, 3, 4, 5, 6. So it is falling 8/6, which simplifies to a -4/3. And finally, line I is the orange line, and it is falling 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and running 1, 2, 3, 4, 5, 6. So it has a -10/6 for its slope, which is simplified to -5/3. So once we've found the slopes, we need to decide if they are parallel and if they are perpendicular. So parallel lines, remember, have the same slope, and perpendicular have opposite reciprocals. So opposite signs and the fraction is flipped. So when we look at these, we notice that line F and line G both have a slope of 3/4. So we want to say that F is parallel to G, and our symbol for parallel is the two lines, showing that they are following the same direction. And then we notice that -4/3 and 3/4 are opposite reciprocals. So H and G are perpendicular. And because -4/3 and the slope of F are also negative reciprocals or opposite reciprocals, then H is also going to be perpendicular to line F. So knowing what you know, you should be able to do number 5. Number 6 asks us to determine if the lines are parallel, perpendicular, or neither, and they've given us points on the lines, but they have not actually graphed them, so we can't rise and run and count, but we can calculate the slope like we would up here. So we're going to take line 1 and find our change in y over our change in x. So our y2 minus our y1 is going to be a 2 minus a -2, which becomes 2 plus a +2. And then our x2 minus our x1 is 0 minus a -6, so 0 plus 6, so 4/6. And that simplifies to 2/3. Our slope of line 2, we're taking the y minus the y over the x minus the x. So our y on line 2 is the 1, -1, and a -1 minus a +1. The x's are the 3 and the 6, so we're taking 3 minus 6. We get a -2 over a -3, and a negative over a negative is positive, so that will be a 2/3. Because the lines are the same, these lines are parallel. So you can write the word parallel, or we can simply say parallel with our symbols. So that is how you would do 7 and 8. Now we need to figure out how we're going to find an equation of a line through point P that is parallel to this given line. So here's our point P, it's at -2, 5. And we want to know what line is going to be parallel to this line. And so we're going to, or through this line, through this point. So we're going to need to know our equation of lines. So one of them is y equals mx plus b, where m is the slope, when the y is all by itself, and the b is the y-intercept, where it crosses the y-axis, the line crosses the y-axis. So the key here is the y has to be all by itself. The other one is point slope, and point slope has a point and a slope in it. And it's y minus its coordinate, or take away, change the sign of its coordinate, is equal to the slope times x minus its coordinate. And so we want to, first of all, decide what the slope of this line is, but because the y isn't by itself, we have to solve for y. So that's a two-step process. We'll subtract 3x, and a negative 2y equals negative 3x plus 4. Since negative 3x and 4 are not like terms, they can't be combined. And then we want to divide every single term by this negative 2. And y equals a negative 3 divided by negative 2 is simplified to 3/2 x, and 4 divided by negative 2 is a minus 2. So that is our old line with our old slope, which is 3/2. Because we want these lines to be parallel, we want to use the same slope. So we're going to use 3/2 with this point. So there's our point, and our slope is 3/2. The easiest form to use is the point-slope form, since we have a point and a slope. So we can say y, change the sign of the y-coordinate, is equal to our slope times x, change the sign of the x-coordinate. And that is an equation of a line in point-slope form rather than slope-intercept form. So then we need to graph the two lines. Our first line had a slope of 3/2 and a y-intercept of a negative 2. So we go to negative 2 on the y-axis, and we rise 3 and run 2. Rise 3 and run 2. And draw our line. Our second line has a slope of 3/2, but this line goes through the point negative 2, 5. So we can go to negative 2, 5 and rise 3, run 2, or we can fall 3 and go left 2. And this is our other line. These two lines should be parallel to each other. When we get to question number 12, it's the same process, but this time we're looking for perpendicular lines. So we need to have opposite reciprocals for the slope. So y equals mx plus b, or y minus y sub 1 is equal to our slope times x minus x sub 1 in parentheses. So our first line has the slope apparent and visible for us. It's already there. If the slope is 2/3, this is our old slope, then our new slope must be a negative 3/2. So we want to go through this point, negative 4, 3, with a slope of negative 3/2. That means that we can use our point-slope form and say y, change the sign of the y-coordinate, is equal to our slope times x, change the sign of the x-coordinate. So that is our new equation of our line. So we can draw this line from negative 4 up 3 is our first point on this line, and then we can fall 3 and run 2, because our new slope is the opposite reciprocal of our original. So if we fall 3 and run 2, we can draw our new line. Our original line had a slope of 2/3 and a y-intercept of -5. So we go to -5, and we rise 2 and run 3 this time. For lines to be perpendicular, they have to have opposite signs for their slopes. We can fall 2 and go left 3. And these two lines should form a right angle if we have nice straight lines. So remember, on 13 and 14, you want the perpendicular lines. That means we need to change the slope to have opposite reciprocals. Our last example is number 15 in a box, and we want to find the distance from point P to a line. The distance, how far apart is point P from this line y equals 2x minus 4. So we can start by graphing y equals 2x minus 4, rising 2, running 1 from -4. So here is our line. And we want to know how far away from this line is point P. So point P is the point is at 6/2 down. And we want to know how far is it from point P to this line. So if you were trying to find the shortest path from a point to a line, you want the perpendicular distance. The perpendicular distance, because that's the quickest way to get there. So we don't want the point from the red dot to this dot or this one. We want to figure out what the closest to the shortest distance is. And the perpendicular distance will have a opposite reciprocal for the slope. So because the slope was 2 here, our perpendicular distance is going to have a segment connecting it. It will have a opposite reciprocal -1/2 for its slope. That means we would go down 1 over 2 or up 1 left 2, up 1 left 2. And so we want to know how far is it from our red dot, which was 6 -2, to our line, and our perpendicular distance to that line will hit at, or it will intersect at the point 2, 1. So you can use the distance formula, or you can ask yourself, how far horizontally are we? How far is it between 2 and 6 horizontally? That's 4. And between our y-coordinates, how far is it between, apologies, to 0, between 0 and -2? That's a -2, or 2 as a positive distance. And since we have a right angle here, we can use the distance formula, or we can say the distance is the square root of a squared plus b squared. Our horizontal distance was the 4. The vertical distance was the 2. 4 squared is 16. 2 squared is 4. So our answer is the square root of 20. And square root of 20 has a perfect square in it. It is the square root of 4 times the square root of 5. The square root of 4 is 2. So our final answer is 2 times the square root of 5. The bottom are bonus questions. You're welcome to try them. It's good to have a challenge and see if you can figure them out.